Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello. So this is the last video for chapter number 4, polynomial. So for this video, we discuss only two subtopic. Number one, a factor theorem, which is they're related with the remainder theorem from the previous video. And another one is factorization of cubic expression using long division plus remainder theorem and the factor theorem. Okay, so how do we factorize completely without using the calculator, especially for the cubic expression? Alright, so what does it mean by this factor theorem? Before this, in the remainder theorem, actually the easiest way to identify the remainder for a specific division between two polynomials. However, for the factor theorem is the most convenient method to use when faced with the problem of factorizing a polynomial. Okay, so rather than you find out the factor, other than use your calculator to determine the correct factor for that quadratic, actually you can use this factor theorem to determine the factor. Alright, so similar like the remainder theorem, for the factor theorem, we're going to substitute our divisor, for example x minus t, and then we substitute into the polynomial with the positive t. If and only if when you substitute the value of your x into the polynomial, they give you a zero remainder. Okay, similar when you substitute with the negative t, okay, when you have x plus t, you substitute negative t into the polynomial, also they give you a zero remainder. So therefore, this x minus t or x plus t be the factor to that polynomial. So once you have one factor, you can either factorize use long division to find the other factor. Okay, so let's take a look at this example. The question asks you to use the factor theorem to show x plus 1 is a factor of x cubed minus 2x squared minus 13 plus minus 13x minus 10. Okay, they ask you to use this factor theorem. Okay, what do you understand about this factor theorem? Factor theorem means when you substitute this x plus 1, which is x plus 1 equal to 0, therefore your x equal to negative 1. So when you substitute negative 1 into this polynomial, they should give you a 0. Okay, this is what I mean by the factor theorem. Okay, so let's take a look at the process. So this is your polynomial. When I substitute using the factor theorem, I will substitute negative 1 into the polynomial, and I have to show that they will give you a 0. Okay, see how we have changed the sign because of the theorem saying that when you have x plus t, then you will substitute negative t into the polynomial. So when I substitute my value into the polynomial, okay, so whenever I have x, I will substitute with the negative 1, similar like this. Okay, so when I substitute, I have a 0. So what is the suitable conclusion over here? So therefore, x plus 1, which is our divisor, is a factor for the polynomial given. Okay, so this is how we prove whether your divisor be a factor of your polynomial. You must to show that whenever you substitute your x value, you will have 0 remainder. Meaning, if let's say you substitute, you have another value other than 0, then you will decide that your divisor is not a factor to this polynomial. Alright, so let's take a look at the question from Delta. So you can try the exercise from 12.03, page number 221. Alright, so over here, I'm going to show you question number 1. Right, working and some conclusion calculation to show that x minus 2 is a factor of x cubed minus 11x plus 14. So since I have x minus 2, then you equate this x minus 2 equal to 0, then I know that my x equal to 2. Therefore, I substitute 2 into my polynomial. So whenever I have x, I will substitute with 2. Therefore, I have a 0 over here. So my conclusion is x minus 2, which is our divisor, is a factor of the polynomial. You can try for the rest of the question number 2 and number 3. Okay. Now, factorization of cubic expression. So factor theorem is used to factorize polynomial. The method relies on substituting carefully chosen number into the polynomial until the value 0 is obtained, thus indicating a factor. We test the factor theorem by trying out the possible roots in turn. Let's say they ask you to factorize cubic expression without given any divisor. Then how do we know what is the suitable divisor to use? So over here we'll try and error to determine what is the suitable factor for this polynomial. Let's take a look one example. So the question asks you to determine the factor of x cubed minus 5x squared plus 2x plus 8. Without given any divisor, how to factorize this one? So actually, I know that you can simply press your calculator with your a equal to 1, b equal to -5, c equal to 2, and d equal to 8 using the mode of EQN, and you choose degree 3 because your expression over here is a cubic. Okay, so actually, the correct method to determine the factor is we are going to find at least 3 roots because this expression is a cubic. It will have 3 factors and therefore 3 roots. But what is the root that we're going to use? So each root must be a factor of 8. Why we have 8? When substituting number into a cubic, it's also necessary to try to factor of 8. Again, why we choose a factor of 8? Usually, in order to determine the factor, you're going to look at the last term over here, the constant term, because they will determine whether you have a remainder or not. So therefore, you have to start your try and error using the last digit in your polynomial equation. So now we are going to determine the factor of 8. Alright, so over here I list out the factor of 8. You have 1, -1, 2, -2, 4, -4, 8, and -8. How do I know? Try to divide each number over here with 8. So 8 divided by 1 is 8. It's a divisible, so 1 is a factor. 8 divided by -1 will be -8. Also, -1 is a divisor. So meaning that when you divide each number over here, they give you a whole number without any fraction, without any decimal. So that number is a divisible to this 8. So therefore, factor 8 is over here. So therefore, we are going to try and error for each number of that I list out over here and determine whether you have a 0 remainder. So let's take a look to the next table. So we have to test all factor of 8 using the factor theorem. Remember, when you substitute into the polynomial, then they give you 0, meaning that your x value is a factor to this polynomial. So when I substitute 1, I have answer of 6. So 6 is not a 0. So meaning that 1 is not a factor. Let's continue to the next one. When I substitute -1, then I have a 0 remainder. So meaning -1 is a factor to this polynomial, meaning that x plus 1 is one of the factor to this polynomial. Okay, try the next number. When I substitute 2, into the polynomial, then also I have this positive number. Okay, I have a 0, so meaning that 2 is also a polynomial. Sorry, 2 is a factor to this polynomial. And you can continue to the rest of the x value. -4, 8, and also -8. When I substitute into this polynomial, only 3 number that give you a remainder 0. -1, 2, and also 4. So what is the suitable conclusion over here? So by using the factor theorem, automatically I know that x plus 1, x minus 2, and x minus 4 is a factor of our polynomial, because all our value over here give a 0 remainder using the factor theorem. So factor theorem is very useful in order to determine our factor for the polynomial. So meaning that you have to try and error. So I have a tips how to determine the value. Okay, so it's very easy actually. Alright, we test the factor theorem by trying out the possible root in turn. You can choose any number. Let's say we start with x minus 1 and factorize completely using long division. If you substitute 1 into your polynomial, you didn't have the 0 remainder, so therefore you have to try another number, let's say x plus 1, into your polynomial. You substitute your x equal to -1 and check whether your polynomial gives you a 0 remainder. So you can determine that this x plus 1 is one of the factor of your polynomial. And after that, you can use the long division to determine for the remaining factor. Remember that when you have a cubic, suppose you will have 3 factor for your polynomial. Okay, so you can try and start with x minus 1. If not, if when you substitute the value into the polynomial, they didn't give you a 0 remainder, therefore you can try for the next one, which is x plus 1. Usually one of these number will be the factor of the polynomial. What happen if not? What happen if x minus 1 and also x plus 1 didn't give you a 0 remainder? So here is the tips. You can substitute your polynomial into your calculator. Okay, determine your A, your B, your C, and also your D into your calculator. Use the mode of EQN and degree number 3, and your calculator will help you to determine one of the factor. Okay, so by using that factor, you just show that like this. Okay, so let's take a look using try and error method that I mentioned just now. So we start with either x minus 1 or x plus 1. So here is the first sentence that's important. Let x minus 1 be the factor of the polynomial, or let x plus 1 be the factor of the polynomial. So in your examination letter, so you have to show that you test one of the factor, because you don't know yet, without using your calculator, you don't know yet what is the factor of this polynomial. So that's why you have to show all the try and error method. So you have to try at least one factor. I know that you can get a factor from your calculator, but you have to show us at least the try and error method. Okay, continue. So when I substitute 1 into my polynomial and also -1 into the polynomial, when I substitute, I have 6 and also 0. So therefore, x minus 1 is not a factor, but x plus 1 be the factor, right? So therefore, x plus 1 is the factor. So x minus 1 is not a factor. So this is the first step that you should have in your step in order to determine the factor of this polynomial. Okay, so you have to show this step. At least you try one of the possible factor. Okay, next. Since the question asks you to factorize completely, we will continue the process using the long division. So now we're going to divide our polynomial x cubed minus 5x squared plus 2x plus 8 with x plus 1 be our divisor. Okay, so it's going to be like this. So this is going to be the step number 2 after you determine one of the factor. So by using the long division, we are going to divide this polynomial with our divisor. Okay, so the next step will be you determine what is the suitable multiplication to x plus 1 in order to eliminate the first number here. So let's say I choose x squared. Why I choose x squared? Because if I multiply x squared with x, then I have x cubed over here. And then easy for me to eliminate this number. Followed by x plus 1 multiply with the x squared, then I have positive x squared. Okay, so the first multiplication between which is x squared, and then you subtract this number, therefore I have 0 for x cubed minus x cubed, but negative 5x squared minus with the positive x squared, so negative 5 minus x squared, therefore negative 6x squared. Continue again, try to eliminate this negative 6x squared. Therefore, I will multiply with the negative 6x. Because if I multiply this negative 6x squared to this x, I have negative 6x squared. Right? If I bring down over here to x, then I have negative 6x multiply with 1 negative 6x I have. Right? So bring down, then I multiply with the negative 6x, then I have negative 6x squared minus 6x. And then you subtract this number, then I will eliminate this negative 6x squared. But for this 2x minus 6x, so 2 plus 6 equal to positive 8x. And then bring down this 8, you bring down this 8, therefore I will multiply my x in order to eliminate this 8x. I will multiply with another 8. So I multiply with the positive 8, then I have 8x plus 8 also. Then I have a 0 remainder if I subtract between that two. So what is the instant conclusion over here before we continue with the last step, which is we have to factorize completely. Now I know that when I multiply between this quadratic x squared minus 6x plus 8 with x plus 1, they will equal to this polynomial. Okay, alright. However, the question asks you to factorize completely. So therefore, we are going to proceed the process using the calculator. So now, substitute your value over here into your calculator to determine the remaining factor. Use the mode of EQN with the degree 2. You substitute your A equal to 1, B equal to negative 6, and C equal to 8. Right? After you substitute, I believe your calculator will give you these two factors. So this is how we factorize completely. You have to make sure you have to expand this polynomial, the sum of term, into the product of term. So therefore, the conclusion will be the polynomial equal to x minus 1, x minus 4, x minus 2. So you can try the rest of the question from the delta, page number 221, exercise number 12.03. Right? So please try and you can check your answer in your delta. Thank you. See you in the next video.